in Houston area. Worked at NASA 38 years, born in Galveston. So I'm BOI. If you're BOI, you can run for mayor in Galveston, right? But you have to be born on the island. And so I got over here in January. I'm the new executive director for PISCES, Pacific Space Center. And so it's great to see that there's a wide, diverse group here, all the way from students to those that are retired and doing other things. And so, Rod, is it this one?
I think it's that one, yep.
That moves? So I think this is a really interesting, compelling story. And first of all, I want to thank Rod for inviting somebody from Hilo side come all the way over to Kona side and talk story. I mean, it's not often that Hilo side gives a chance and an invitation to come over and talk on Kona side. So I am so excited to be able to do that today. And so I'm the executive director. I'll tell you a little bit about the Space Center and then a lot of the projects that we're working in and who we are out of that. But first, a little question. So when I did Journey last year, which outreaches, it should be an island thing. Right now it's just in Hilo. But all the astronomers, our center, we go to every classroom, K through high school, over a week and talk about space. And of course, based upon your relevance. So I talk about manned spaceflight program and the interesting things that I did. So I ended up talking with 2 or 3 classes a day. And after the first day, I got to tell you, I did 2 classes and it was in the morning and I was exhausted. I just had to go home and sleep. I don't know how teachers do it. It was just exhausting to me to go do that for just 2 classes. But so I would give these questions about space to the kids to get their mind going. And so I'm going to do that with you as well. So we know that spiders need gravity to make spider webs. You know, they get into a corner and gravity pulls them down as they descend with gravity. They let out the little silk thread. And then they climb up again and drop. And then they make lateral pieces and then they spin their web. So the question is, can spiders make a spider web in space without gravity? So raise your hand if you say, no, can't be done. They got to have gravity, right?
Define web.
Yeah, it looks like a spider web. Can they make something that looks like a spider web? It's got cross pieces. It's got the little spirally thing going on, right? So how many think they cannot do it? Won't work, right? Okay. How many think that they can make it? Right? Sure. How many have gone, I'm not raising my hand, this is embarrassing, I didn't come to raise my hand, I just want to sit here. Actually, this was a student experiment that was flown on NASA's first space station back in 1973, and a student came up with this idea of the very question, could spiders make a spider web in space without gravity? And actually, her name was Arabella. They actually had 2 spiders up there and had a little food for Arabella to eat. Went up on space station, had a little box for her, and actually she did make a web. And what she did, it was fascinating to see the video, she would get in one corner of the box and then let go. And when she lets go, she drifts. And as she drifted, she let out her web, her string. And then she'd hit the other side of the box and latch on and attach that right there. And then she'd let go and she'd drift to the other side of the box, attach on there, and then ultimately she drifted enough where she got cross pieces, and then she could spin a web. Now, it wasn't as nice and pretty as we see here, but she was actually able to make a web in space. Pretty cool stuff. So we do that kind of stuff with the students to just energize their mind and their thinking. So I wanted to do that with you today. So the Space Center, Pacific Space Center, used to be a part of UH Hilo. A year ago, there was legislation to take it out of the university, and now we're state funded. We get money from the state. We're a part of the Department of Business, Economic Development, and Tourism. And our focus now, with me coming on board in January, is to really do applied science, to do applied research and development in areas that both support Hawaii and the space program. So our focus since 2007, since it was created, was planetary surface systems, drills, rovers, things that can take advantage of the unique geologic aspects of Hawaii. There is really no place else you can go that has lunar and Mars type of terrain, geology, morphology like Hawaii does. And now that has expanded into lava tubes. Over just the last couple of years with the high-rise camera at Mars and now the Lunar Reconnaissance high-definition camera, for the first time, we have uncovered skylights, lava tubes, and pit craters on Moon and Mars and Venus. Didn't know they existed before. And so we don't know what it looks like inside of these things. So there's a number of groups that are very interested in doing robotic missions to get inside of lava tubes. And so where can you go to test technologies associated with lava tubes? This island, especially on the south side, on the Mauna Loa side, has some of the most incredible lava tubes, all the way from the Thurston tube that's very large, all the way to ones where you have to get on your belly and crawl through just to get from tube to tube. And so there's fascination of looking robotically at some of these capabilities. So we're a planetary surface system organization, look at technologies on how to live off the land, and I'll talk a little more about that. But these next three were really big to me, impressed upon me when I got here in January, when I talked to the academia, the businesses, the industries, the Billy Kenoi and the council. Three things. One is 21st century jobs and 21st century skills. There's a real lack of that in Hawaii. And so because there's not high tech industry to keep the people here, they get trained here and then they'll find a job on the mainland. So creating 21st century skills for 21st century jobs is a big thing for the legislature. And then also creating economic development and then workforce development jobs. So all three of those play very heavily into our mission in life. But we also want to leverage the unique geologic resources for the sites that apply to Moon and Mars. In fact, back in 2010, the instrument that is now on Mars Science Laboratory, Curiosity, sitting on Gale Crater, was tested here on the flanks of Mauna Kea. And its name was Kemen. And it looks at the geocomposition of the basalt. I mean, all the islands are made out of planetary stuff. The same stuff we have here is on Moon and Mars. It is that geologically unique. And so what Kemen said, when it got to Mars, it looked at the sample of Gale Crater at Mars and found that the geochemistry of the lava there, the basalt on Mars, is exactly like the flanks of Mauna Kea. So the press, a year ago, November 1st of last year, worldwide press was Mars like Hawaii, Mars like Mauna Kea. It just went nuts around the world about how close it is. And that's part of the unique aspects and attractiveness of Hawaii to planetary surface exploration. And our job, too, is one of the reasons we were taken out of university was twofold, is to get more stable funding from the state than we can get through the university, and also to make it easier to do strategic relationships. So I'm all about networking and relationships, as we all are in business. And so it's important for me to tie into internationals, tie into the federal government, and tie into the private sector. And so we're able much easier to do that outside the university than within. Now, this is an interesting paradigm that describes exactly who and what we are and why we are. And I was talking with the governor last January about that. He wanted to know about the Pacific Center. Where could he help? What kind of bills do we need? Where are we going? What is our job? So I told him that Hawaii is very much like the International Space Station that's flying up there. They just had a docking system, a crew module with all the supplies for the crew, food and clothing, just docked yesterday up on the International Space Station. So the space station has to be refueled, food has to come up from the Earth, propellant has to come up, oxygen has to come up. It has to be continually resupplied from Earth. Just like Hawaii is. We have gotten to the point in the state where we can't be self-sufficient anymore versus the way the forefathers lived and living off the land. 94% of our energy comes from the mainland. We import 300,000 tons of Portland cement plus asphalt over that for roads, houses, everything that are not indigenous to this island. And so we are very much anchored by 2,400 miles in this chain over the mainland. And so the legislators, the governor, want to become more self-sufficient. They want to become more sustainable and less reliant on having to import things, whether that's oil and energy, raw materials, to be able to live more off the land. The reason it ties well in space is when we go to Moon and Mars, we can't do it like we did in Apollo in the late 60s. You remember that. We took everything to the moon with us to live for a few hours on Apollo 11 to 3 and 4 days in Apollo 16 and 17. We can't do that when we go back. We have to be able to live off the land. You have to be able to extract oxygen out of the basalt regolith. You have to be able to stabilize the surface and make launch and landing pads and shelters all out of basalt material, because it's too expensive to take oxygen and water and building materials to Mars and Moon just to do that. So you have to be able to live off the land. So this idea of sustainability and living off the land is exactly what the governor is interested in doing legislatively in applying to our technologies. So every technology I look at that I'll share with you in terms of construction, energy, robotics, is all tied to not only validation and verification of technologies that can be used on Moon and Mars and living off the land, but also has to have a direct translation capability, a dual-use technology into Hawaii itself. Does that make sense? Hawaii has to have some return on the investment. They have to have some ROI in the deal. It has to have some benefit back to the state, not just to the people that want to go to Moon and Mars and asteroids. So these are the technologies that we're working on that are pretty incredible. We've built this portfolio over the last few months. Advanced communication technologies, 3D printing, robotics, construction materials, prospecting and mining technologies, and then education, public outreach, and then a technology park that will be a few years down the road. So let me briefly walk through what's going on with some of these technologies. It's really incredible. One of these is advanced telecommunications. Right now, the way we communicate with our cell phones and wireless and all that is through radio frequency, RF. But President Obama and Congress are really pushing more broadband technology, which is part of the portfolio of the governor, and doing more technology development in broadband. And so the industry is going more toward laser-based communication. So ultimately, the next communication satellites that will be launched at the end of the decade won't be RF linked. They'll be laser linked. So NASA wants to come put a laser ground terminal here in Hawaii. And the reason Hawaii is very important is that lasers in clouds and lasers in atmosphere don't work very well together. You get a lot of spread and distribution out of that. So you have to get very high and you have to get above the cloud layer. Does that make sense? So that Hawaii offers some unique places here to do that. And then this ground station would communicate with deep space probes through lasers with all that data coming here into Hawaii. And we're talking 10 to 100 gigabits of data, huge data rates. And so it will be with a 1 meter telescope that will sit somewhere in Hawaii, probably in the 2016-2017 time period. Prior to that, they want to put an advanced weather station. They want to get 2 years of climatology data at the test site to understand how the weather changes over time. So there's a benefit of just climatology from NASA to Hawaii just in that. And they want, interestingly, a part of the deal is that the university has to create curriculum and development and classes in advanced laser and optics communication and weather. And then also provide the manpower for maintaining, operating, repairing both the weather station that would go in 2014 and the advanced laser station that would go in 2017. So pretty incredible. So how does that tie into my site? Well, I'm getting an advanced rover that comes from Canada here in December. So, over the last few years, we've discovered water on the moon. Back when I was a shuttle flight director and back in Apollo, we thought the moon was airless and no water existed there at all. Boy, have we been wrong. We have rewritten the book on the moon. There are tons of water that is trapped below the surface and in permanently shadowed craters on the moon from cometary ice and hydrogen from the sun interacting with the regolith. And so the idea is, how do you get to that so you can live off the land? So one of the missions that's going to the south pole of the moon in the spring of 2017 is going to use a Canadian rover. So this company in Canada is wanting to send us that to get robotic expertise on the rover to develop that prior to it going to the moon in 2017. So we get a long-term loan of a planetary rover here. It is probably the size of this thing. It's a pretty big system. It's a big boy. And then we're also going to use it for a technology, not only a pathfinder for state-provided infrastructure of communications, power, mechanical systems that I provide, but also as a sensor platform for student experiments. So students can put experiments on the back end of this thing. We go up and operate on Mauna Kea or Mauna Loa, looking for different things on the geochemistry or the different type of basalts, and they get the data, they design the experiment. So we're very excited about that. So how does the rover then and the laser tie together? Well, one of the ideas for what to do with humans in space is telerobotic operations, really high bandwidth operations, where you need really a lot of bandwidth to do a lot of dexterous operations. It's kind of like Robonaut, moving hands and claws and picking things up, and you need a lot of bandwidth to do that. So NASA is interested in having the International Space Station crew hook the laser up through a geosynchronous satellite, then down to our rover, and them doing teleoperated commanding of the rover. And then this would pathfind what they would do on the far side of the moon, many miles away, 2,000 or 3,000 miles away from the backside surface of the moon, to command robots on the far side of the moon where we don't have telecommunication. And then do the same thing at Mars, where they, from elliptical orbit around Mars, they would command robots and building habitats and runways and landing pads prior to crew arriving there. So this is a thing where we can take advanced communications and apply that into STEM and technology development that supports not only Hawaii, but also space. Another area that we're fascinated in getting involved in is 3D printing. So everybody's going nuts in 3D printing. Are you familiar with 3D printing? It's these devices that make these little masks and little toys, and they make it out of Lego plastic or ceramics. And it has just gone berserk in the world. A lot of high schools have them. You can get them, MakerBots, for about $2,000, and you can make all these little objects out of plastic and ceramics. So we're interested in doing that, but not with plastics. We're interested in things that can live off the land. So we're not going to take plastic with us. We're not taking ceramic to Moon and Mars. We have to live off of what's there. What is there? It is the basalt material, just like we have on Hawaii Island. So what we want to do is laser-based 3D printing that actually melts and reformulates the basalt soil into making objects. So now we make a wrench, we make a hub for a wheel for the rover. I make different parts for my rover, all out of planetary material that is right here in Hawaii, right? It's really cool stuff. Nobody is doing that stuff. And so one of the things we're also interested in doing, NASA did some tests of some of the planetary basalt for a heat shield. Could you use volcanic basalt for a heat shield, Moon and Mars? They put it in a big ArcJet testing laboratory and had great results. It really withstood the heat. So NASA called us, and they have this idea of building 8-inch by 8-inch pavers that interlock for fireplaces, for patios, and for flame trenches of launch pads at Kodiak, at Barking Sands, at Kennedy Space Center, up at Merritt Island, up in Virginia, at the Stennis launch engine test stands in Mississippi. A lot of groups, commercial groups, are doing vertical takeoff and landing, and it destroys the concrete runway. It spreads debris, and so you get high velocity particles going in every direction. So Hawaii could actually make these things with 3D printing and then export them with Made in Hawaii on that. So again, how we could create entrepreneurial companies in 3D printing with basalt materials. So this is really hot for me. Nobody's doing this, and people are just going nuts on that. So that's some of our basalt material right here. And you know where that comes from, by the way? It comes out of the quarries. So the rock crushers in the quarries break down the rocks that they use for different things. Their waste product, the stuff they throw away that they don't know what to do with this, are these -200 fines or basaltic powders, flour particles, right? Type particles that they don't know what to do with. It turns out that's probably exactly what we need to do 3D printing with the lasers. So another area that we're interested in doing is what I call literate concrete construction. is taking the basalt material, instead of importing lots of Portland cement and asphalt, is how can we use the indigenous material here to make houses, roads, sidewalks. So the county of Hawaii is very interested in this, doing test pads, 3 foot by 3 foot test pads of the basalt material with various binding agents. So we're looking at maybe putting it down for playground materials or sidewalks. Geofoam is actually aerated concrete. There's actually a group in Honolulu that makes this. It's not load-bearing systems, but it's flame resistant, it's extremely light. I mean, you pick it up with nothing because it's aerated. And so we're looking also, could we do, instead of concrete aerated foam, could we do this with basaltic foam? No one's done that either. But what we want to do is look at different basalt materials and additives that bind the particles of the basalt together, that hold it together to make it as hard as concrete. So we're looking at protein binders, we're looking at polymers, different polymer sets or thermal polymers that can actually hold all the basalt together. And so we're looking at volcanic ash and also fly ash that comes out of the H1 reactor. So we're talking with Sarah Malama about that. She's very interested in what do we do with that waste product, that fly ash, as a part of using it as a binding agent. Then protein binders. This is actually lignins that come out of blood to bind the basalt together. We've got some of that in our office that's absolutely hard as brick. And then polymer sets that could bind that together. So we're very much into applied research. And then even better. So what we want to do is take 3D printing technologies and now expand that into three-dimensional structures, 3D printed houses. So the way we make houses today, right, you do it with bricks or you lay out slabs of concrete and then you lift them up. So now there's some machines under development that actually have 3D print heads, and you can actually 3D print a house in 48 hours. So it could represent jobs, industry, new technologies. And so that's what we have to do at Moon and Mars. These are some examples of like an igloo or habitat, all made out of planetary basalt material like we have in Hawaii. So what we want to do is bring those technologies in, test them for application at a planetary scale, but also have it as a spin-off technology that could create construction jobs here on the Big Island. And so this is examples of 3D printed materials that could be a domed enclosure, for example. And this is using the same type of systems to stabilize the surface that's very floury so that you don't get a lot of blowing dust for launch and landing pads, landing aprons, that type of thing. We're also very interested in the energy side because we can't take the oxygen and all that with us to do energy. We have to live off the land. So solar is a great way to do that. So we're looking at a group called Planetary Power that uses, this is SunSpark, and it uses concentrated solar technologies into a thermal head up here, and then it heats that in a Brayton cycle and creates high efficient energy use. And so the neat thing about this is that it's off-grid power that we could use our test sites up on Mauna Loa, because there's no place for us to go plug in power out there. But if we have disasters and large power outages within the Big Island, we can deploy these guys around and get kilowatts of hours of power that could supply hospitals and emergency capabilities. So we're interested in bringing in advanced technologies that could apply both to Hawaii itself, but also could be used on planetary surfaces for energy. Another area is in advanced aerial robotics. This is a really interesting story because it came about last November. The Japanese were over at our conference right down here at the Hilton, and they told us the story of when the tsunami hit Fukushima, the nuclear power plant there in Fukushima, and just utterly destroyed it. So the Japanese wanted to go in, but didn't want to send people because of the unknown radiation environment and that it may not be structurally sound. So they wanted to send in aerial robotic systems. So they brought in this rover to go do the inspection from one of the Japanese universities, but nobody had a trained operator, and they couldn't let the power company operate it. The power company didn't want to operate it. They weren't trained in it. So they didn't have an operator for the robot. They had to go to the United States to get the rover and the operator to go do the inspection of this nuclear power plant. So their suggestion is that Hawaii, giving its mid-Pacific central location, could be a great hub for telerobotic training and operators out of the university, out of the Hawaii Community College. In fact, I met a fascinating lady, just got back from Afghanistan over on Hilo side a week and a half ago, and she flies these aerial drones for the Air Force. And I said, what are you, a first lieutenant? Are you a captain? She goes, no, I'm a corporal. And so they've got these people that haven't even been going to college yet, but they can do all this PS3 stuff, like my five kids. They're really good at this, right? And they fly these $1 million machines over in Afghanistan and looking for the bad guys, sending missiles on the bad guys. So this could be even a job market for infusing the military people after they retire that do actually telerobotic operations. So we're interested in aerial systems that could be used for disaster management, civil defense, and emergency response services when we have earthquakes, typhoons, that type of thing that come and affect the island. So we even got more. Last Friday, we met with Helco. So right now, Helco, to do power line inspections and damage inspections, they rent helicopters, and it's extremely inexpensive. So you got to get a pilot, you got to get a helicopter, you got to pay for all this fuel, and then you're going up and down Saddle Road, or you're going around the island looking at these power lines. It is big bucks. So we talked to Helco about using these with unmanned aerial vehicles, these quad or octocopters that have 2 to 3 kilograms of payload weight. You put a UV camera on, like over here, and you can get high voltage arcing into the air, or you can look at with infrared for heat signatures of problem areas on the power lines for where are the trouble spots, and then do close-up inspections if you need to do that. So we're looking for Helco to be a strategic partner in application technologies for doing high voltage power line inspections. So again, we are constantly thinking, how do we have application technologies back into Hawaii? I don't know what I just did right there. Oh, and the other one that's fascinating is what we're applying this to Space Ag, what I call Space Ag, space agriculture. So it's putting these different hyperspectral imagers on this that can look at plants and agriculture and determine where the diseased plants are versus the non-diseased. Where are you getting too much irrigation and not enough irrigation? Where are you getting too much nutrient and feeding versus not enough? And so the county is going nuts on this. This might be our #1 bill coming into the legislators this year with Richard Onishi, because they want to tie it into the borer beetles that are attacking the coffee farms. Can you identify where the beetles are and then have countermeasures to that? We're also looking at bunchy top that is affecting the banana plants. And then I talked to the guy at the macadamia nuts, the mac nuts and Royal Orchards. He's got issues as well, but it's not widespread, it's tree to tree. So identifying which trees have the fungus and the disease issue, and then using the aerial systems to do spot spraying within the tree systems itself. And of course, you have to have operators that are really able to manipulate and train and fly these things. And that's where we think Hawaii Community College and the universities could be an important pipeline into this. So we're actually doing a pilot project with Hilo right now this fall, looking at some ground truth on shipment property. And then hopefully if we get the bill approved, then we'll really expand this into a big major effort next year. Just quickly, the technology park, the government here, the legislators want us to bring in big technology industries, which is a barrier right now. We have a hard time attracting the Boeings and the Lockheeds and the Northrop Grummons. And so we're looking at a distributed model that might look for various locations that best fit them. Like Planetary Power, we brought them over a couple months ago, and they really like the Kona site, tying in with the energy lab over here. But another group may be better situated up in Honolulu. So we're headed toward a distributed type of model and trying to versus shoehorn all the industries into one park. So we're off working that. So our long-term capability is that we want to do advanced technology verification and validation for planetary surface systems. But at the same time, we want to have this tied back into this concept of Hawaii's sustainability and 21st century jobs. And then secondary from that, in the longer term, do a distributed research part. just a couple of STEM things. I had 5 students. I got 4.5 people working for me right now. We've got all these projects. I don't have enough people. So I hired 5 students over the summer. One was using telescopes to look at the moon to characterize where light that is emitted from meteors hitting the moon. Prior to the launch of the LADEE spacecraft that was a few weeks ago. LADEE's going to circle the moon and look for lunar dust, evidence of lunar dust. And 4 other students went and did site characterization for me. So I had 2 students in geology. I had 1 student that was a biologist looking for, good plants versus bad plants in the test sites. And then I had another one that was doing geospatial imagery, geolocation of items within the test site. So they did 2 test sites up on Mauna Kea, and then they did 2 lava tubes for me. And now we're going to expand that and do more of that next summer. We're also we're getting a lot of interest from NASA in what's called the Abadox competition. This competition has been done at the Kennedy Space Center for the last 4 years with over 50 teams from all over the world. India, Bangladesh, South Africa, Australia, Canada, and they come to Kennedy with their little rovers, and they are mining robots. And you have to get in this pit, and you go to the end of the pit and you collect lunar simulant, sand, and then you have to rove it back over to the other end of the pit and dump it. And you have to transport, and dump 10 kilograms over 10 minutes type of thing. So we had the University of Alabama that won it 2 years ago come out last November and test at Mauna Kea. And they went absolutely nuts. They said, this beats by far anything that they're doing at the Kennedy Space Center. They don't have real stuff. You got real stuff. And so now NASA wants us to have an international competition in robotics, in planetary mining, resource mining, where the winner from Canada comes here to Mauna Kea and tests. The winner from Australia comes. The U.S. winner comes. The Japanese winner comes. South Africa winner comes. This year, this coming summer, we'll probably have 4 or 5 teams as a trial and do it up on Mauna Kea in June. So the idea is kind of like the Little League World Series, right? Where all the teams come from all over the country of the world, and then they go to Williamsport, Pennsylvania for the final Little League World Series. It's the same type of thing here. And so this is a big push for us in STEM education and robotics. And we just got money from the county to add to ours. And the State Department of all groups is wanting to contribute this as well under USAID, USA. And this is one that's really passionate for me. I started at NASA right out of high school. I hadn't been to one day of class when I started at NASA in May of 1973. And so I missed the last Apollo landing by 6 months. It really bothered me. I've always wanted to be a part of the lunar program. And I missed it by 6 months. It still bothers me. So I'm really passionate about having a Hawaii student experiment to go to the lunar surface in 2015. We don't have much time. So a number of these commercial groups under the Google Lunar X Prize, privately funded, are creating these landers and rovers to go to the moon. And you have to, once you land, you send a high definition image. You have to move 500 meters and send another high definition image. And if you do that, you get $20 million from Google. Second prize gets 10. And so we're working with a number of groups. There's one group that is planning to go in the spring of 2015. So if I'm to do this, I've got to get all this put together so that the spring and the fall of next year would be able to put this experiment together with high schools across the Hawaii, because I have to deliver the hardware at the launch site probably in February of 15. So I've got just a little over a year to go do this, right? And we're looking at maybe 2 opportunities. And the one that I want to do is the electrostatic removal of dust. There's so much iron in the dust, and it's very corrosive. It's very prickly. It gets into everything. It gets all over the spacesuit, the radiators, the solar arrays. It's a huge issue. So if we can electrostatically repulse the dust, kick it off, it is going to be a huge benefit. Well, NASA's been doing technology development on this, but can't get it to the moon. But I think I can get it to the moon with 3 high schools working on it. So one high school working in hardware, computer-aided design, coil units, another group working software and avionics, and another group doing the science, field operations, and flight operations of the thing. So it involves three high schools into this thing. And then I wanted to do it philanthropically funded, privately funded from the rich people in Hawaii. So that's the trick. They got to find the rich people. If you know some, I need to talk to you. So this is a big passion for me. Also, I want to mention that we have Dr. Abby coming over. Mr. Abby ran the astronauts for a year. You didn't fly in space if you didn't get through Mr. Abby. And he ran the Johnson Space Center for many years. And he's right now a part of the James Baker Institute at Rice University. And George is coming over here to speak in about a week, October 10th at 6:30 at Emiloa on STEM. STEM has just gotten really poor in the United States compared to other international countries. And so he's going to talk about science, technology, engineering, and math. He's going to talk about the education in our system. He's going to talk about how that applies to aerospace. And so this speech is really oriented toward educators. We're trying to get any teacher or administrator all the way from the university down to kindergarten that teaches science or math to come to the lecture series. It's free at 6:30 on the 10th. It's on the website. So so the teachers here, we would really encourage you to come participate in that. We're trying to do one of these lecture series maybe once a quarter in like space biology, space medicine, space architecture, space policy, space politics, different than the astronomy groups do. This also is very important. The October 8th, next week, we are having a state summit on aerospace in Honolulu at the Capitol so that we can get lots of access to the senators and representatives. So who's coming to this? So business, industry, academia, entrepreneurs, economic development, the legislative side, the lieutenant governor speaking. The governor happens to be out of town next week. So we're getting all these different diverse groups together to chart the vision forward for what aerospace ought to be doing in the state of Hawaii. And how does education then adjust and balance for updated curriculum to be able to support that need? This is important timing because it's during the fall time period that we craft the bills legislatively that go into the spring session. So we want to influence the legislators in this. So within that, we're going to have advanced manufacturing, suborbital tourism and research, unmanned aerial vehicles, green aviation technologies. So it's going to be a really interesting discussion for a day and a half in the Capitol next week, and it's also free. So aerospace means business. We're trying to be not overtake or by any means do away with tourism, but we're trying to be a new sector that better balances the portfolio relative to the state to tourism. Have another economic input that is jobs, skills, that better balances the portfolio within the state economically. So thanks for letting me come and share. I appreciate, hope some of this was of interest to you, some fascinating areas that we're doing in applied research. And if we've got time, I'll take a few questions.
Absolutely.
None. Okay, I did. Oh, this man.
We talked a lot about education and programs within the more formal learning style, traditional sense. As far as educating the general public here in Hawaii, is there any program that kind of bridges the gap between historical Hawaii?
Oh, yeah. Great question. Did I send that question to you to ask? So this is big for me because I'm fascinated by the early Hawaiians living off the land, coming here, and they didn't bring all the supplies with them. They lived off the land with all of the salt material. You see this in their houses and the sidewalks and all that. So this concept, when I talked it over on the mainland over the summer, of settling Hawaii and selling space is fascinating to people. They think that's an incredible story of the forefathers coming over here to settle Hawaii and using that analogy of how we settle space, how we settle Moon and Mars. So I'm working with Emiloa and also trying to work. I know Claude, Ellison Onizuka was on my first space shuttle mission. I did the very first DoD flight for shuttle. And Ellison and I got to be very good friends. He died in the Challenger accident. And so Ellison and I, he was the first Hawaiian astronaut. Ellison and I were really good friends, and I know Claude Onizuka from that, and Claude runs the Onizuka Space Center here now. So I'm trying to involve Claude into this, Bishop, and curriculum and exhibits and things that tell that story. But you have to make it fascinating, where it's a pull to the public, where they really get that. And so I think it's a wonderful story of settling Hawaii, settling space that we're investigating with Emi Loa right now. Yes, sir.
Well, you mentioned once about Hawaii being great because you could get lasers from space down here without the interference. But then it just comes here. How do you get it to the mainland? Or maybe it's going to be used here.
Oh, no, actually, then what we do is couple into the fiber optic lines off the mountain down to like Hilo or Waimea. And then from there, it gets shipped on high bandwidth fiber lines back to the U.S. So the command and control will be overdone in the mainland, and this will be the ground station for that. But it will be controlled from over there, but the station will be here. And you do all that through linkage through fiber optic lines. The interesting thing here is that we have fiber over on Mauna Kea. We really don't have fiber on Mauna Loa. So this is a great opportunity. If we put it over on Mauna Loa, which is probably better culturally, and it's less sensitive with the laser, then it'll help us get fiber put into that area of the Big Island.
Do we have plenty of fiber going from here to the mainland?
Oh yeah, there's tons of fiber. We just have to tie into that from the hubs. Yeah.
Has there been much research, development, or advancements in wireless energy transmissions?
Yeah, good question. So, two things on that. Texas A&M and Japan actually did an experiment from Mauna Kea across to Haleakala, but it wasn't. It's still so early in the development that they haven't gotten it where you can transmit enough power and get it received. They could barely light a light bulb. So there's a big debate between microwaves and lasers in transmitting power. Now, the interesting thing is that some of the groups that want to go investigate these permanently shadowed craters on the moon, what they want to do is have the little lander sit at the rim of the crater and the rover go down in there, but send power down to power the rover. And so power beaming is getting to be very of a great interest, both from the DoD side as well as planetary surface systems. So, great question.
What about electrogravitics as far as for the lunar modules? Is it a fuel combustion system that is taking the module off the moon, or is there much research into using electricity to produce that?
Yeah, it's not so much. The propulsion systems are really chemical, so the idea is to get to the water on Moon and Mars. And then you can break the water into hydrogen and oxygen through electrolysis. And now you can breathe the oxygen, you can make water to drink, or you can use it for hydrogen and oxygen for propellant, for the rocket engine. So they're still looking at methane as another option. By the way, one of the great things that's of interest to the ag groups here on the Big Island is to look at biodegenerators, taking some of the invasive species and you put them into these digesters with some bacteria, and it turns the plants into fertilizer, potassium, carbon, and nitrogen that you can put in the farm. The output of that is methane. You capture the methane, and then you put it in the back end of these energy producers, so now you can also power the farm. So we're actually looking at some plots of land over on the east side to do closed-loop cycles of energy and fertilizer and plants out of that. So actually Planetary Power is very interested in taking that methane into their power head for an alternate energy source. So, yes, ma'am.
Well, I know there's a bunch of students who would be like, oh my goodness, all those projects, they sound really neat. Like, what is the procedure for kind of, getting involved or just coming to check things out, or how does that work?
Yeah, we're just putting up a website to this, but we also are very, very strong in outreach and engaging of the student community in both robotics and other areas. So we're very open to talking with students. Probably the best place is the website.
Okay.
We're just now getting it up and running. It was not very good before, and now we're just this week we're getting it up. So.
What is that website?
So if you go and Google PISCES.com or .gov, there's actually a government link. We're state government, so Pacific Space Center, it'll come up. Yes, ma'am.
I'm going to go back to the question that I asked in the first place.
Yes.
And the reason I'm interested in this is number one, I did work for the Chamber of Commerce when the telescopes came in.
Yep.
And the scientists that were in the telescope, they were very excited about being on the mountain and the Institute for Astronomy.
Yes.
But they couldn't buy a house. They couldn't send their kids to school. Their wives couldn't find jobs. They had no intellectual stimulation. So we lost a few. We managed to keep a few through sheer will until we could build the infrastructure. And actually, I think the telescopes subsidize housing and schooling for their children. And so those are the kinds of problems that you get on a small island.
Yep.
That doesn't have, in Kona, we don't have a university per se. We don't have a higher education system. We don't have a state that's interested in higher education or that's provided it for our students. So while it's great to talk about all this, I love it, it's wonderful stuff, but unfortunately, all we're doing is looking at bringing more people from the mainland.
No,
Because
actually,
we don't have local people to make these jobs work.
Right.
You can, whatever you say, we don't have.
yeah. So, and that's the catch-22 that I see this state has gotten into,
Big guess.
because there's not a pull to generate the 21st century skills and the jobs and all that here. And because there's not the jobs, industry doesn't want to come in, because if they come in, they got to bring all the people with them. So we're in this catch-22, and so what we're trying to do is work with the university. Like now, they're setting up, I think, a Westside campus over here. Don Straney's on our board.
Who knows?
Huh? Who knows?
We've been working on it for 20 years.
Okay.
We'll see.
And they're putting in a brand new engineering department at the university. So we're actually working hand in hand with them, trying to influence the faculty that they hire in optics and in lasers and communications.
That's great, but what about the 10th and 11th graders? What about the students that they want to hire for those?
Right. So the thing is, you've got to establish some tracks, right? So if we can identify some engineering or science type of skilled jobs, then it can be a pipeline that you can pull all the way up through secondary education into the schools. So, it's how do you get the kids to go to UHE or Manoa and then have jobs that they're employed here within the state instead of training them and then they go to the mainland for the job. So we're trying to help in our own small way of battling that.
It still works out. I grew up here. And I went away to college and I came back.
Yeah. I was born in Galveston. I came here, so. But we're trying not to do that. We're trying to where we can build it from within. The economic base, the education base, relative to high-tech jobs. One more question? We good? Well, thanks for letting me come and share. I hope it was of interest to you.